Hello guys, welcome to the next lecture on the GATE mathematics. Today I will explain you how you can solve the Newton-Raphson method related to the numerical analysis. Myself Dr. Harish, you can simply follow my YouTube channel where you can find the playlist of the GATE mathematics and you can see the previous PY question series with the help of the shortcut tricks on the various topic available at my here. I am sure that if you watch this completely, you will crack all the examination in a very simple manner. So let's start with this video. So before I directly move on the PY question, I will tell you the various shortcut tricks which will help you. You can solve each question within a 10 to 15 second in your coming examination. Make sure you have to watch this video till at the end so that you can learn various shortcut tricks in a very simple manner. So as we all know what is the Newton-Raphson method, this method is used for finding the root of the equation f of x is my 0. And the iterative scheme is given to be this one. Now once you know about this iterative scheme, the first question arises is whether this is convergent or not. If this is the convergent, is it always convergent? And if it is not always convergent, then what would be the condition for this? And we all know what is the condition for the convergent is if you have the iterative scheme like of this, then the condition of the convergent is my here. So if you compare this equation by here, you will get this is my g, and when you take the derivative of this function and substitute here, you will get this is the required condition for the convergent. Make sure you have to remember this condition, and it's a very easy, you can remember that f into f double dash is less than of f dash square. Whenever this condition satisfied, then the Newton-Raphson method is convergent. If this condition not satisfied, then it is not convergent. Fine, this is the first remark for you. Second concept is, as you can see, whenever this value is my very large, that means whenever this value goes to the infinity, this whole term will goes to my 0, then you can see the Newton-Raphson method will converge. So whenever the first derivative is a very large number, then the Newton method is very useful. Second most important property is Newton-Raphson method is useful when you are finding the complex root of the equation. Like here, you can find also this root of this, that we all know root is my plus minus iota. So by using the Newton-Raphson method, you can find the complex root as well. However, the bisection method, regular falsy method, secant method, fixed point iteration method is not able to find the complex root of the equation. So Newton-Raphson method is useful for finding the complex root as well. Whenever you are talking about the convergence, that is means the order of the convergence, we all know that it's a quadratic, but make sure it's a simple root. What does the meaning of the simple root is? If f of x is my 0 is the equation, alpha is my root of this equation, that means f of alpha is my 0 and f of dash is my non-zero, then only you can say this is my simple root. Whenever you find the simple root, or you can say the multiplicity of the root, you can say the multiplicity of x is equal to alpha is my 1, because the first derivative is my non-zero, you can say it's a 1. So whenever the multiplicity is 1, then the quadratic convergence is here. On the other hand, when you have the double root, what does the meaning of the double root? F of alpha is 0, f dash of alpha will be 0, now it's a double root, and the second derivative is my non-zero. That means the multiplicity is my 2. Whatever the derivative is my non-zero, then we could say the multiplicity is my 2. Whenever the multiplicity is 2, then the order of the convergence is my linear. There is one more result. If I prove that f of alpha is my 0, f dash of alpha will be 0, f dash of double dash is 0, and f of triple dash is my non-zero, then the multiplicity is my 3. Again, it is my linear order of convergence. So in general, when we say of the function f of x has multiplicity m. Fine. And if m is my greater than 1, then the Newton's method has order of convergence linear. And whenever m is equal to 1, then the order of convergence is my quadratic. This is a very, very useful tips for you. As I told you, the Newton method is a conditional convergent. Whenever this condition holds, then only convergent. And finally, when the first derivative is my very, very small number or approximately 0, then the Newton method is not applicable. The last concept is what is the multiplicity? As I told you, it has a multiplicity m. What is the meaning of that? The mth derivative is my non-zero, and all those previous derivatives are my 0 at the point alpha. This will be the 0, second derivative will be my 0, and so on. That is the m minus 1 derivative is my 0. Then again, as I told you, whenever m is my greater than 1, then the Newton's method has linear order of convergence. Whenever m is equal to 1, then the Newton method has quadratic rate of convergence. If you want to find the rate of convergence, then the rate of convergence is my m minus 1 over m of the Newton's method. Whenever you have the multiplicity m, which is my greater than of the 1, then instead of the Newton's method, we will apply the modified Newton's method, and the formula will be my here. Make sure you have to read the statement very carefully whether the modified is given to you or not. If modified formula is given to you, then the rate of convergence or the order of convergence is my quadratic. However, if modified word is not given to you in the statement, that means they are talking about the Newton-Raphson method, and whenever you have the multiplicity m, then the order of convergence is linear. So there is a very, very minute difference between them. So based on these shortcut tricks, I can solve all those PY questions in a 10 to 15 second time period. I hope you can like, subscribe and comment on my videos as well. You can join with me through my barcode. You can join with my WhatsApp group through this scan code. So let's start with this question. You can see that this is my Newton's method, and if you compare this is my modified Newton's. So firstly, you can check whether the modified word is given to you. You can see it is not given. So it means this question is not from the modified method. Now read the statement. What is the meaning of the double root? What is that? X is equal to xi. It means this value is 0. F dash of xi is my 0. And f double dash of xi is my non-zero. And your target is to find the order. So remember always, order of the convergence is multiplicity of the root. Root in this case is x is equal to xi in the f of x is my 0. As I told you, if this multiplicity, that is a m, if this multiplicity is my 1, then the order is quadratic. If this multiplicity is my greater than 1, then the order is my linear. Now you can see that the second derivative is my non-zero. M is my 2, which is greater than 1. So what is the order? Order is my linear. Fine. So what is the meaning of the linear is 1. So the right answer is B is my correct answer. You can see you needed just this much to get your right answer. Look at this another one. F has an isolated 0 of multiplicity 3. It means xi is my root, multiplicity 3. First derivative is 0. Second derivative is my 0. Fine. And the third derivative is my non-zero. So what is the meaning of that? M is my 3, which is greater than 1. So order of convergence is linear. But if you look over the statement, they are talking about the rate of convergent. Fine. So the rate of convergent is, as I told you, it is my m minus 1 over m. So m is my 3, so 2 over 3. So it is not a cubic, it is not a quadratic, faster than linear, it is not greater than 1. So this option is also cancelled, and only option left is the linear is my right answer. Look at this another one. To find the positive square root of a by solving the function x square minus a. By the Newton-Raphson method, it is here and so on. Okay. So whether xn is strictly increasing, decreasing, constant, not convergent. Firstly, we will check about the convergent. Can you find the Newton-Raphson method? It is fx divided by derivative. So if you take the LCM, I can take x, half is common, x square, 2x square plus minus, so it's a xn square, minus minus plus over 2 is outside xn. How you check the convergent? If I take the limit of the xn as n approaches infinity is L, so it will be L half L square plus a over L. So what is that? It's a 2L square, which is L square plus a. So that means L is my plus minus a. Now since x naught is my positive, so L is my positive, which is my finite number. So once it's a finite number, it means this scheme will my convergent. Fine. So this option is cancelled. Now, how you can say whether it's increasing or decreasing or the constant? So I can see about here. Xn plus 1 is half xn plus a over xn. Fine. So for the sake of simplicity, I can simply say a is my 1. So it means my function is x square minus 1. So I can substitute here. This is my xn plus 1 over xn. Now, what is the root is? 1 is lies between 0 and 2. Fine. So I can choose any initial number. Take, okay, 1 is the root. So I can simply choose any initial number, say 0.5. I can't take as a 1 because 1 is itself the root of the equation. What is my x1? If I substitute here, it is 0.5, and the reciprocal of this, it's a 0.5 plus of 2. So it's a 2.5, it's a 1.25. I can find the x2, half 1.25 plus, if I divide them, what is that? It's 100 over 1.25. So 25, 5, 25, 4. It's a 0.8. Fine. So it is my 2.05 divided by 2. It is 1.025. Now clearly say, he said xn is greater than equal to 1. First number is 1.25. Then 1.025. That means it's a decreasing. So it's a constant, cancel out, increasing, cancel out. Right option is my A is the correct answer. You simply take the one number and get the right answer. Okay, look at this another one. The order of the convergence. What is that? Order of convergence is dependent upon the multiplicity of the root in f of x is 0. Fine. So what is given to you? It has the double root. That means f of xi is my 0. F dash of xi is my 0. F double dash of xi is my non-zero. So what is my m? M is my 2, which is greater than 1. So that means the order is linear. So you can see how many seconds you are needed to solve the problem. Maximum 15 seconds you are needed to solve this problem. And that much 15 seconds you are needed to like and comment on the video. I hope within a 15 seconds you can like and comment on the video as well. Okay, look at this another one. If f of x is given to be my here x square minus 3x plus 1, with the Newton-Raphson method, initial guess x naught is given to be my 1, and find the first approximation. Fine. So we all know what is my first approximation, that is x naught minus f of x naught divided by its derivative. So what is the function value at the x naught? 1 minus 3 plus 1. This is minus 1. Can you find the first derivative of this? 2x minus 3. So what is the first derivative at the initial point? It's a minus 1. So I can substitute here 1 minus 1 divided by minus 1 is a 0 is the right answer of this problem. Again you can see maximum 10 to 15 seconds you are needed to solve the problem. Okay, look at this another one. Using the Newton-Raphson method, initial guess x naught is given to be 6. Function value is given by x log to the base 10 minus 4.77. Then your target is to find the x2, second equation. So I need the first derivative of this. It is my 1 plus log of 10x. Then by the Newton-Raphson method, I can use xn plus 1 is x minus fx, x log x minus 4.77 over 1 plus log x. I can take the LCM so that x log x will be cancelled out. X plus 4.77, 1 plus log of 10 to the x. Now that's over. I can find the x1. x1 initial guess is 6. 6 plus 4.77, 1 plus log to the base 10 of 6. So I can use my calculator and I get this value 0.568. What is the x2? I can substitute this value again here, 0.567 plus 4.77, 1 plus log to the base 10 of this number. I can again use my calculator and I will get as 6.08. So that is my right answer of the problem. You just look about this statement and follow the simple procedure. Look at this next question. Suppose the Newton-Raphson method for the function f of x is 2x square plus 1 minus this. Fine. With the initial approximation x naught sufficient closer to the 0, then the order of convergence. Again the order of convergence is dependent upon the multiplicity of the root in f of x is equal to 0. What is the root? Root is given to be 0. So I can check about the multiplicity. So f of 0, f dash 0 and so on. What is the f of 0? 0 plus 1 minus 1, which is 0. What is the f dash? If I found the derivative of this, it is my 4x plus 0 minus 2x e raised to power x square. So what is the f dash of 0? 0, 0. Fine. So clearly say, and if there is no need to find the second derivative because we got as f2 is 0, f0 is 0, f dash is 0, f double dash 0. It may be 0, it may not be there. So we got at least m will be my 2 because it has a double root. So once m is my greater than 1, what is my order of the convergent? Order of convergent is my 1. That's a linear. So 1 is my right answer. But if you want to find the second derivative, I can find you 4 minus 2 will be outside, 1 into x square minus plus 2x square e of x square. Then what is the second derivative of the 0? It is 4 minus of 2, 1 plus 0, which is my non-zero. Fine. Whatever, if the second derivative is 0, for example, then you will get as m is equal to 3. If this is 0, then you will get a 3, which is again greater than 1. Answer is again 1. So my right answer is 1 is the right answer. Again you can see the 15 seconds you are needed whenever there is a question related to the order of convergence. Okay, look at this another one. Again they are talking about the order of convergence, Newton-Raphson method about the root. So that means we have to check about the multiplicity of the root in the f of x 0. So root is my 2. What is f of 2? I can substitute here 16 plus 16, 4, 44, 24 plus 36. So this is my 32 minus 68 plus 36, which is 0. Now I can find the first derivative, 4x cube 6x square minus 24x minus 12. Then derivative at the point 2, 4 8 32, 4 24, 4 48 minus 12. Fine. So it is my 56 is it is 32, sorry, 4x cube, 6x square minus 24x. Fine. So add the root 2. So 8 for 32, 4, 24 minus, sorry, it's a 22. 11 to 22x. So when you take x is equal to 2, it is my 44. Then 56, it is again 56, which is 0. What does it means? Whenever you have f of 2 is 0, f dash of 2 is 0, it means multiplicity is at least 2. Fine. So it means m is at least 2, which is greater than 1. So the order of convergence is my 1. There is no need to find the third derivative. But if you want to find the second derivative, we can see it's a 12x square. It's a 12x minus 22. What is the second derivative of at the point 2? 4, 48, 24 minus 22, which is non-zero. So m is my 2, which is greater than 1. So that means the order of convergence is my 1. F is my twice differentiable function such that f dash is my less than 0, means decreasing. F double dash is less than 0, means concave. For all x is in my here. I think it's a simple. Can you choose any of the function which is a concave? 1 minus x square is a very simple function. F of xi is my 0. So eta, can you find this value? Eta will be 1. And eta is lies between the a and b. So 1 is lies between 0 and 2. Fine. I can make it calculation simple. I can choose these examples. Then this is the Newton method scheme. xk belongs to eta and b. Fine. For some k, then which of the following statements are my correct? So I can write this formula. What is the xk plus 1, which is xk minus f of f. F is my here. So 1 minus xk square divided by minus of 2xk. So I can written minus is here. So I can take the LCM, 2x square minus minus plus 1 minus xk square divided by 2xk. That means xk square plus 1 over 2xk. So I can simply say xk plus 1 is half xk plus 1 over xk. Fine. I can take 2 as a common. Then which of the following statement is here? Now you can see I can choose any xk in between them. Fine. So I can choose xk is my 1.5. Fine. So what is the x of k plus 1? Is a half 1.5 plus 1 over, that's a 10 over 15, 5253, that's a 0.66. I can write up to the 2 decimal places. So it is half. What is that? It's a, if I have to add them, it will be my 2.16. So that will be my 1.08. Fine. So that means xk plus 1 is my 1.08. xi is my 1. Is it greater than? Yes, satisfied. 1.08. Is it less than? No, cancel out. 1.08. xk is my 1.5. Is it satisfied? Yes. And for this f of eta is lies between xi is my 1, xk is 1.5. Fine. So what is the f dash of eta? I can write for you here. Fine. What is the f dash of eta? What is the derivative is minus 2 of eta. Choose any number in between them. Say 1.1 is open interval, so 1.2. So minus 1.2 means it's a 2.4. What is the denominator is f dash of xk minus 2xk. xk is my 1.5, it is my minus 3.0. So if you substitute on the left hand side, is it greater than 1? No. So it means this option is cancel out. So right answers are A and C are my correct answers. You can see a very simple approach. You can simply take the one example and discard the options. Okay, look at this another one. F is the any function which is twice differentiable, has only one root. That means f is 0. This is my non-zero. What does it means? Multiplicity is my 1. So once is a multiplicity 1, it means the order of convergence is my quadratic. F dash and f double dash are the second, and this alpha is my simple root, that's the meaning of here, and compute by Newton-Raphson method. Then the method convergent. Okay, they are talking about the convergent condition. So as I told you, firstly f double dash f dash of square, that's the condition for the convergent. So f into f double dash less than of this correct option, f into f dash, that's the wrong, f dash into f double dash wrong, f into f double dash, but square is not given, so the right answer is A is my correct answer of the problem. Okay, look at this another one. The scheme is given by again the Newton-Raphson method. Now they are talking about the multiple roots, multiple equation. That is a system of the equation. You have the two equations, minus, and second is my here. Fine. I called first one is f1, second is f2. Then if you look about the first equation, xk plus 1 is xk plus f. Then they are talking about the values of the f. Compare this equation by the Newton-Raphson method. What is that? It will be minus f divided by the derivative. But right now they have that more than one variable. It means the derivative is my partial derivative. So that means the partial derivative. So either x or y. Now since they are talking about the x, so this is the partial derivative of x. So what is the minus f1 is? Minus x square plus y square minus 10 divided by partial derivative of f1 with respect to x is the 2x. So that's the right answer. So this option is cancelled because the first one is f. This is divided by 2x is not there, divided by something else, and you can see this is matched. Since all these other options cancel, the right answer is here. But I will tell you the second way also, how you can find this g. This is, if you compare them, it is my minus f2. This is with respect to y, so I can differentiate this function f2 with respect to y. So what is the answer of this? Minus, what is the derivative of f2 with respect to y? This is x square, and you can see the same option satisfied at here. So A is my right answer of this problem. Okay, look at this another one. One root of the function f of x is e raised to power x minus 3x square is lies in the interval of this, the least number of the iteration of the bisection method. Okay, they are talking about the bisection. Okay, you know what is the formula for the number of the least number of the iteration? Log to the base 10 b minus a minus error divided by log of 2. That's over. Fine. What is the a and b? These are the intervals. A is my 3, b is my 4. What is my epsilon? This is my error. So if I substitute here, log of 4 minus 3 minus log 10 raised to power minus 3 divided by log of 2. Log of 1 0, log is my plus 3 divided by log of 10 2. So what is the right answer of this? If you divide them, it is my 9.9 something. It is greater than or equal to. What is the least number which satisfied? Clearly say it is my 10 is my satisfied. So clearly say 8 is not greater than 9.8, 6 is not greater than 9.9, and here. So the right answer is A is my correct answer. Look at this another one. Again you have to find the equation. F of x is x e raised to power x minus 1. It lies between 0 and 1. What is f of 0? Negative. F of 1, e minus 1. So e minus 1 is the positive. Fine. The two iteration by the bisection method. Very simple. What is the first iteration of the bisection? That is the average, 0.5. Fine. Now you can check what is the f of x1. It is 0.5 e raised to power 0.5 minus 1. So what is that? 2.718 divided by 2 minus 1. So clearly say it is my 1 point something here. So if you use the calculator, you will see this number is my less than 0. So once f is my negative, so it means the next root, so negative, that means here. So I can replace this 0 by this value here. Then what is my x2? Average of this. So right answer is 0.75. So the C is my right answer of this problem. So this is the way you can solve all these questions in a very simple manner. I hope you can like, comment and share my videos as well. We will see the next lecture more on the complex analysis from the GATE examination. Till then, you can simply like, share and comment on my video. Best of luck students. Happy learning.